Pedagogy of Physical Science Part 2. Syllabus Tamil Nadu Government Samcheer 9th and 10th Science Book, Physics and Chemistry chapters. First, we are going to see about 9th Standard Science. In 9th Standard Science, we have 16 units for physical science. The units are measurement, motion, fluids, electric charge and electric current, magnetism and electromagnetism, light, heat, sound, universe, matter around us, atomic structure, periodic classifications of elements, chemical bonding, acids, bases and salt, carbon and its compounds, and applied chemistry. The first unit is measurement. The learning objectives of measurement. After completing this lesson, students will be able to understand the fundamental and derived quantities and their units. Know the rules to be followed while expressing physical quantities in SI units. Get familiar with the usage of scientific notations. Know the characteristics of measuring instruments. Use vernier caliper and screw gauge for small measurements. Find the weight of an object using a spring balance. Know the importance of accurate measurement. Introduction. Measurement is the basis of all important scientific study. It plays an important role in our daily life also. While finding your height, buying milk for your family, timing the race completed by your friend, and so on, you need to make measurements. Measurement answers questions like how long, how heavy, and how fast. Measurement is about assigning a number to a characteristic of an object or event which can be compared with other objects or events. It is defined as the determination of the size or magnitude of a quantity. In this lesson, you will learn about units of measurements and the characteristics of measuring instruments. Physical quantities and units. Physical quantities. Physical quantities is a quantity that can be measured. Physical quantities can be classified into two: fundamental quantities and derived quantities. Quantities which cannot be expressed in terms of any other physical quantities are called fundamental quantities. Example: length, mass, time, temperature, etc. Quantities which can be expressed in terms of fundamental quantities are called derived quantities. Example: area, volume, and density, etc. Physical quantities have a numerical value and a unit of measurement, say 3 kg. Suppose you are buying 3 kilograms of vegetables in a shop. Here 3 is the numerical value and kilogram is the unit. Let us study about units now. Units. A unit is a standard quantity with which the unknown quantities are compared. It is defined as a specific magnitude of a physical quantity that has been adapted by law or convention. For example, feet is the unit for measuring length. That means 10 feet is equal to 10 times the definite predetermined length called feet. Earlier, different unit systems were used by people from different countries. Some of the unit systems followed earlier are given below in table 1.1. Unit systems of earlier times. System, length, mass and time. CGA system. Length of the CGA system is measured in centimeter, mass in gram, time in second. FPS system, length in foot, mass in pound, time in second. MKS system, length in meter, mass in kilogram, time in second. Foot is the singular of feet. But at the end of the Second World War, there was a necessity to use worldwide system of measurement. Hence, SA system of units was developed and recommended by General Conference on Weights and Measures at Paris in 1960 for international usage. SI system of units. SI system of units is a modernized and improved form of the previous system of units. It is accepted in almost all the countries. It is based on a certain set of fundamental units from which derived units are obtained by proper combination. There are 7 fundamental units in the SI system of units. The units used to measure the fundamental quantities are called as fundamental units, and the units which are used to measure the derived quantities are called as derived units. Fundamental quantities and their units. They are also known as basic units and they are listed here. Fundamental quantities, units and symbol. Length, the unit of length is meter, symbol is m. Mass, unit is kilogram, symbol is kg. Time, unit is second, symbol is S. Temperature, unit is Kelvin, symbol is K. Electric current, unit is ampere, symbol is A. Luminous intensity, unit is candela, symbol is CD. Amount of substance, unit is mole, symbol is MOL. With the help of these 7 fundamental units, the unit for other derived quantities are obtained, and their units are given below in this table. These are the derived quantities and their units. For example, area, expression, length into breadth, unit is meter square. Volume, area into height, meter cube. Density, mass per volume, kg meter minus 3. Velocity, displacement slash time, meter per second. Momentum, mass into velocity, kilogram meter per second. Acceleration, velocity per time, m s minus 2. Force, mass into acceleration, kilogram meter per second or Newton. Pressure, force by area, Newton per meter squared or PA. Energy or work, force into distance, Newton meter or J. Surface tension, force per length, Newton per meter. Fundamental units. Length. Length is the extent of something between 2 points. The SI unit of length is meter. 1 meter is the distance travelled by the light through vacuum in 1 by 29,9792,458 seconds. In order to measure very long distance of astronomical objects, we use the following units: astronomical unit, light year, and parsec. Astronomical unit. It is the mean distance of the center of the sun from the center of the earth. 1 AU is equal to 1.496 into 10 power 11 meter. Light year. It is the distance travelled by light in 1 year in vacuum, and it is equal to 9.46 into 10 power 15 meter. Parsec. Parsec is the unit of distance used to measure astronomical objects outside the solar system. 1 parsec is equal to 3.26 light year. Larger units. Larger units, kilometer. In meter, 10 to the power 3. Astronomical unit, 1.496 into 10 power 11 meter. Light year, 9.46 into 10 power 15 meter. Parsec, 3.08 into 10 power 16 meter. To measure small distance such as distance between two atoms in a molecule, size of a nucleus, and wavelength, etc., we use some multiples of 10. These quantities are measured in Armstrong unit. Smaller unit in meter. Fermi F 10 power minus 15 meter. Armstrong 10 power minus 10 meter. Nanometer Nm 10 power minus 9 meter. Micron 10 power minus 6 meter. Millimeter 10 power minus 3 meter. Centimeter 10 power minus 2 meter. Unit outside SI system and still accepted for use. Mass. Mass is the quantity of matter contained in a body. The SI unit of mass is kilogram. 1 kilogram is the mass of a particular international prototype cylinder made of platinum iridium alloy, kept at the International Bureau of Weights and Measures at Sèvres, France. The unit gram and milligram are the submultiples of 10 of unit kilogram. Similarly, quintal and metric tons are multiples of 10 of unit kilogram. 1 gram is equal to 0.001 kilogram. 1 milligram is equal to 0.000001 kg. 1 quintal is equal to 100 kg. 1 metric ton is equal to 1000 into 1 kg, which is equal to 10 quintal. Astronomical mass unit. Mass of proton, neutron and electron can be determined using atomic mass unit 1 AMU, 1 by 12th of mass of carbon 12 atom. Time. Time is a measurement of duration of events and the intervals between them. The SI unit of time is second. 1 second is the time required for the light to propagate through vacuum. It is also defined as 1 by 86,400 part of a mean solar day. Larger units for measuring time are day, month, year, and millennium, etc. 1 millennium is equal to 3.16 into 10 power 9 second. Temperature. Temperature is a measure of hotness or coldness of a body. SI unit of temperature is Kelvin. 1 Kelvin is fraction of the thermodynamic temperature of the triple point of water. 0 Kelvin is commonly known as absolute zero. The other units for measuring temperature are degrees Celsius and Fahrenheit. Unit prefix. Unit prefix are the symbols. Unit prefix are the symbols placed before the symbols of unit to specify the order of magnitude of the quantity. They are useful to express very large and very small quantities. K is the unit prefix in the unit kilometer. A unit prefix stands for a specific positive or negative power of 10. Rules and convention for writing SI units and their symbols. The units named after scientists are not written with a capital initial letter. Example, Newton, Henry, Ampere, and Watt. The symbols of units named after scientists should be written by the initial capital letter. Example, capital N for Newton, H for New Henry, A for amperes, and W for watt. Small letters are used as symbol for units not derived from a proper noun. Example, small m for meter, kg for kilogram. No full stop or other punctuation marks should be used within or at the end of symbol. Example, 50 meters and not as 50 m. The symbol of the units are not expressed in plural forms. Example, 10 kg not as 10 kgs. When temperature is expressed in Kelvin, the degree sign is omitted. Example, 283 K not 283 degree K. Use of solidus is recommended for indicating a division of one unit symbol by another unit symbol. Not more than one solidus is used. Example, meter per second or m/s. J slash K slash mole should be J K minus 1 mole minus 1. Vernier calipers and screw gauge. Vernier calipers. In our daily life, we use meter scale for measuring length. They are calibrated in centimeters and millimeters. The smallest length which can be measured by meter scale is called least count. Usually, the least count of a scale is 1 millimeter. We can measure the length of object up to 1 millimeter accuracy with this scale. By using vernier caliper, we can have an accuracy of 0.1 millimeter, and with screw gauge we can have accuracy of 0.01 millimeter. Description of vernier caliper. The vernier caliper consists of a thin, long steel scale graduated in centimeters and millimeters called scale. To the left end of the main scale, an upper and lower jaw are fixed perpendicular to the ball. These are named as fixed jaws. To the right of the fixed jaws, a slider with an upper and lower movable jaw is fixed. The slider can be moved or fixed to any position using a screw. The vernier scale is marked on the slider and it moves along with the movable jaws and the slider. The lower jaws are used to measure the external dimension and the upper jaws are used to measure the internal dimension of the objects. The thin bar attached to the right side of the vernier scale is used to measure the depth of the hollow object. Use of vernier caliper. The first step in using the vernier caliper is to find out its least count, range and zero error. Least count, least count of the instrument is equal to value of one main scale division by total number of vernier scale division. The main scale division will be in centimeter, further divided into millimeter. The value of the smallest main scale division is 1 millimeter. In vernier scale, there will be 10 divisions. Therefore, least count is equal to 1 millimeter divided by 10, which is equal to 0.1 millimeter, which is equal to 0.01 centimeter. Zero error. Unscrew the slider and move it to the left such that both the jaws touch each other. Check whether the zero marking of the main scale coincides with that of the zero of the vernier scale. If they coincide, then there is no zero error. If they do not coincide with each other, the instrument is said to possess zero error. Zero error may be positive or negative. If the zero of the vernier is shifted to the right of the main scale, it is called positive error. On the other hand, if the zero of the vernier is shifted to the left of the zero of the main scale, then the error is negative. Positive zero error. In this figure, you can see the positive zero error. From the figure, you can see the zero of the vernier scale is shifted to the right of the zero of the main scale. In this case, the reading will be more than the actual reading. Hence, this error should be corrected. In order to correct this error, find out which vernier division is coinciding with any of the main scale division. Here, the fifth vernier division is coinciding with the main scale division. So, positive zero error is equal to 5 into least count, which is equal to plus 5 into 0.01, which is equal to 0.05 centimeters, and zero correction is negative. Hence, zero error correction is zero correction is minus 0.05 centimeter. Next one is negative zero error. Now look at the second figure. You can see the zero of the vernier scale is shifted to the left of the zero of the main scale. So the obtained reading will be less than the actual reading. To correct this error, we should first find which vernier division is coinciding with any of the main scale division. As we found in the previous case, in this case, you can see the sixth line is coinciding. To find the negative error, we can count backward. Here the fourth line is coinciding. Therefore, negative zero error is equal to minus 4 into least count, which is equal to minus 4 into 0.01, which is equal to minus 0.04 centimeter. Then zero correction is positive. Hence, error zero correction is 0.04 centimeter. We can use vernier calipers to find different dimension of any familiar object. If the length, width and height of an object can be measured, volume can be calculated. Calculate the correct reading if the main scale reading is 8 cm, vernier coincidence is 4, and positive zero error is 0.05 cm. Solution: correct reading is equal to 8 centimeter plus 4 into 0.01 centimeter minus 0.05 centimeter, which is equal to 7.99 centimeter. Digital vernier caliper. We are living in a digital world, and the digital version of the vernier calipers are available nowadays. Digital vernier calipers has a digital display on the slider, which calculates and displays a measured value. The user need not manually calculate the least count, zero error, etc. Screw gauge. Screw gauge is an instrument that can measure the dimensions up to 1 by 100th of the millimeter or 0.01 millimeter. With the screw gauge, it is possible to measure the dimension or diameter of a thin wire and thickness of a thin metallic plates. Description of screw gauge. The screw gauge consists of a U-shaped metal frame. A hollow cylinder is attached to one end of the frame. Grooves are cut on the inner surface of the cylinder through which a screw passes. On the cylinder, parallel to the axis of the screw, there is a scale which is graduated in millimeter. It is called pitch scale. One end of the screw is attached to the sleeve. The head of the sleeve is divided into 100 divisions and it is called head scale. The end of the screw has a plain surface spindle. A stud is attached to the other end of the frame, just opposite to the tip of the screw. The screw head is provided with a ratchet arrangement to prevent the user from exerting undue pressure. Using the screw gauge. The screw gauge works on the principle that when a screw rotates in a nut, the distance moved by the tip of the screw is directly proportional to the number of rotations. Pitch of the screw. The pitch of the screw is the distance moved by the tip of the screw for one complete rotation of the head. It is equal to 1 millimeter in typical screw gauge. Scale of a screw is equal to distance moved by the pitch by number of rotation by head scale. Least count of screw gauge. The distance moved by the tip of the screw for a rotation of one division on the head scale is called least count of the screw gauge. Least count of the instrument is equal to value of one small pitch scale reading by total number of head scale division. So here least count LC is equal to 1 by 100, which is equal to 0.01 millimeter. Zero error of a screw gauge. When the movable stud of the screw and the opposite fixed stud on the frame area brought into contact, if the zero of the head scale coincides with the pitch scale axis, there is no zero error. Positive zero error. When the movable stud of the screw and the opposite fixed stud on the frame are brought into contact, if the zero of the head scale lies below the pitch scale axis, the zero error is positive. Here, the fifth in this diagram, the fifth division of the head scale coincides with the pitch scale axis. Then the zero error is positive and it is given by zero error is equal to plus into n into LC, where n is the head scale coincidence. In this case, zero error is plus 5 into 0.01, which is equal to 0.05 millimeter. So the error correction is minus 0.05 millimeter. Negative error, negative zero error. When the plane surface of the screw and the opposite plane stand on the frame are brought into contact, if the zero of the head scale lies above the scale axis, the zero error is negative. In this picture, we can see that 95th division coincides with the pitch scale axis. Then the zero error is negative and is given by zero error is equal to minus 100 minus n into LC. Zero error is equal to minus 100 minus 95 into LC, which is equal to minus 5 into 0.01, which is equal to minus 0.05 millimeter. The zero correction is 0.05 millimeter. Measuring mass. We commonly use the term weight which is actually the mass. Many things are measured in terms of mass in the commercial world. The SI unit of mass is kilogram. In any case, the unit are based on items purchased. For example, we buy gold in gram or milligram, medicine in milligrams, provisions in grams and kilograms, and expresses cargo in tons. Can we use the same instrument for measuring the above listed items? Different measuring devices have to be used for items of smaller and larger masses. In this section, we will study about some of the instruments used for measuring mass. First one is common beam balance. A beam balance compares the sample mass with the standard referred mass. This balance can be used for measuring mass accurately up to 5 grams. Physical balance. This balance is used in the labs and is similar to the beam balance, but it is a lot more sensitive and can measure mass of an object correct to milligrams. The standard reference masses used in this physical balance are 10 milligrams, 20 milligrams, 50 milligrams, 100 milligrams, 200 milligrams, 500 milligrams, etc. up to 200 grams. Digital balance. Nowadays, for accurate measurements, digital balances are used, which measures mass accurately even up to a few milligrams, the least value being 10 milligram. This electrical device is easy to handle and commonly used in jewelry shops and labs. Spring balance. This balance helps us to find the weight of an object. It consists of spring fixed at one end and hook attached to the rod at the other end. It works by Hooke's law, which states that additions of weight produces a proportional increase in the length of the spring. A pointer is attached to the rod which slides over a graduated scale on the right. The spring extends according to the weight attached to the hook and the pointer reads the weight of the object on the scale. Differences between mass and the weight. Mass m is the quantity of matter contained in a body. Weight W is the normal force N exerted by the surface on the body to the balance against gravitational pull on the object. In the case of spring scale, the tension in the spring balance the gravitational pull on the object. When a man is standing on the surface of the earth or floor, the surface exerts a normal force on the body, which is equivalent to the gravitational force. The gravitational force acting on the object is given by mg. Here m is the mass of the object and g is the acceleration due to gravity. The pull of gravity on the moon is 1 by 6 times weaker than that on the earth. This causes the weight of an object on the moon to be less than that on the earth by 6 times. The difference between mass and weight. Mass, it is the fundamental quantity, and weight, it is a derived quantity. Mass, it has magnitude alone, scalar quantity. Weight, it has magnitude and direction, and hence it is a vector quantity. Mass, it is the amount of matter contained in a body. Weight is the normal force exerted by the surface on the object against gravitational pull. Mass remains the same everywhere. Weight varies from place to place. Mass is measured using physical balance and weight is measured using spring balance. Mass unit is kilogram and weight unit is Newton. Accuracy in measurements. When measuring physical quantities, accuracy is important. Accuracy represents how close a measurement comes to a true value. Accuracy in measurement is centered in engineering, physics, and all branches of science. It is also important in our daily life. You might have seen in jewelry shop how accurately they measure gold. What will happen if little more salt is added to food while cooking? So it is important to be accurate when taking measurement. Faulty instruments and human error can lead to inaccurate values. In order to get accurate values of measurement, it is always important to check the correctness of the measuring instruments. Also, repeating the measurement and getting the average value can correct the errors and give us accurate values of the measuring quantity. Points to remember. Quantity which cannot be expressed in terms of any other physical quantities are called fundamental quantities. Example, length, mass, time, temperature, etc. Quantities which can be expressed in terms of fundamental quantities are called derived quantities. Examples, area, volume, and density, etc. A unit is the fundamental quantity with which unknown quantities are compared. Length, mass, time, temperature, electric current, intensity, and mole are the fundamental units in SI system. To find the length or thickness of smaller dimension, vernier caliper and screw gauge are used. Astronomical unit is the mean distance of the Sun from the center of the Earth. 1 AU is equal to 1.496 into 10 power 11 meters. Light year is the distance travelled with the light in 1 year in vacuum. 1 light year is equal to 9.46 into 10 power 15 meters. Parsec is the unit of distance used to measure astronomical objects outside the solar system. 1 Armstrong is equal to 10 power minus 10 meter. SI unit of volume is cubic meter or meter cube. Generally, volume is represented in liter. Least count of screw gauge is 0.01 millimeter and least count of vernier calipers is 0.01 centimeter. Common balance can measure mass accurately up to 5 gram. Accuracy of physical balance is 10 milligram. Important concept: meter, kilogram, second, ampere, Kelvin, mole, and candela. Meter, distance the light travels in a vacuum in 1 by 299792458 of a second. Kilogram, mass of an international prototype in the form of platinum iridium cylinder kept at services in France. Second, length of the time taken for 9192631770 periods of vibration of the cesium-133 atom to occur. Ampere, it is the current which produces a specific force between two parallel wires which are 1 meter apart in a vacuum. Kelvin, it is 1 by 273.16 of the thermodynamic temperature of the triple point of atom. Mole, amount of the substance that contains as many elementary units as there are atoms in 0.012 kilogram of carbon 12. Candela, intensity of a source of light of specified frequency which gives a specified amount of power in a given direction. Need to find out the answer for the following. First one, choose the correct answer. 4, choose the correct answers are given. Find out the answer. 5, fill up is given. Fill in the blanks are given. You have to find out the answer. State whether true or false. If false, correct the statement. 6 statements are given. Correct it. Match the following. 2 sets of match the followings are given. Match it. Assertion and reason type. 3 assertion and reason types are given. Find it out. Answer very briefly. 6 questions are given. You have to write the answer very briefly. Answer brief. 4 brief answer questions are given. You have to answer it briefly. 2 detailed questions are given. You have to answer in detail. Numerical problems. 4 numerical problems are given. Find the answer for that. Summary of the lesson. Measurement. Under measurement, we have learned 3 concepts. One is SI system, systems of units. Under that, SI system, fundamental units, derived units, rules and convention for writing units. The second one is physical quantities. Under that, we have learned 2 fundamental quantities and derived quantities. The third one is measuring instrument. Under that, we have learned about vernier, screw gauge, spring balance, common balance, digital balance, and digital vernier. Good luck. Thank you.